Good afternoon. How many talks have you heard today? Who's counting? Right? Yeah, who's counting? I was hoping Abhinav Srivastava will go because I was kind of going to make some jokes about you, but now all my plans are, yeah. So anyway, well, I got my PhD in 1981 at Purdue University, and after 4 years in Midwest, the only place you want to go and work is California. So I went to University of Southern California. I was there 81 to 91. Too much good weather. And I said maybe I should come to East Coast and suffer with the rest of the humanity. So I came here in 91. But the real reason why I came here is in the next slide. So let's see. There you go. Computer vision has a special place at University of Maryland. The picture you see is the picture of my mentor, Professor Asriel Rosenfeld. And he came here in 1964 and started working in image processing in those days. And so you can see a history of all the professors who came here at various points. And Professor Larry Davis is now on leave of absence with Amazon. And Professor Hanan Samet, you already heard from him today, and Professor Jacobs. And of course, I can make some stories as to why there is all these differences between the years in which we hired these people. But I guess that's okay. But Asriel is considered as one of the founding fathers of computer vision, right? And he was the first to come to work. He was the last to leave. And he'll come, and first thing he'll do is make a nice pot of coffee for everybody else, because he realized coffee is important for producing papers. And he's a mathematician. They say a mathematician's role is to convert coffee to papers. So he really followed that. I mean, joking aside, we had pretty much, if you take the people here in the computer vision, we have worked on every problem one can imagine. In fact, when I was here as a student in 1979, and then I used to, I had dual things between here and Purdue. These days, everybody is, making a big deal about interning. I was interning those days. I used to be here during spring breaks and Christmas breaks and so on and work with Asriel. I remember a conversation in his office where he was imagining, let's imagine putting some sensors on a vehicle and let the vehicle go around this campus and see what it can do. This was early 1980s. So the project ALV, Autonomous Land Vehicle, was born in the mid-80s, funded by DARPA. And Maryland was one of the performers, right? So that's the kind of vision he had, and we moved a lot of things because of him. I don't have time to discuss all of this. Look at some of these important facts. 300 PhD students. I mean that's a very conservative estimate because we don't keep track of everybody. Students, once they start making money, they don't contact us because they're afraid we are going to hit them for money. Suddenly, all my students who went to Bay Area, etc., I can't even trace them. Address not known. Email has changed. So we don't keep track of everybody, but look at all that, right? Amazing. Professors we have produced, and professors we are able to attract, and so on. And I put top 3. I forgot Berkeley. Maybe top 4. Berkeley is okay, See, when this field started in the mid-70s, the top universities were CMU, MIT, and Maryland. We used to have a program from DARPA, Image Understanding, 76 to 1992, basic research. And then it became more applied and so forth, right? So if you have interest in working in computer vision, you have come to the right place. If you are not interested in working in computer vision, it's okay, but you probably will change. All right? So, okay. I'm a professor in ECE, but computer science people seem to like me enough to give me an affiliate appointment in their departments. I produce many CS students. And I speak computer science to my engineering faculty. I speak engineering to computer science faculty. And if both of them are there, I speak cricket. So it has worked out very well. The reason why I'm saying it in this way is that the type of mathematics we use is different. Computer science, a lot of discrete mathematics, trees, graphs, and structure representations. And, of course, you have the matrices from there. In ECE, we are very big on control, signal processing, probability inference, and so on. Some of these overlap. Like there's Professor Srinivasan here who does a lot of randomized algorithms. And so if you are CS, you are busy with the discrete structure, learn some stochastic things, learn some probability and so forth. Then people are afraid of you. Anytime you put a little big expectation operator or a small p probability density function, people think, this will, right? So, don't just stick with your thing, because these days everything is connected, right? So, and again, always remember, you just have to know enough to be dangerous. Okay, so these are some of the things I've been involved with. I have a large group of students, and I enjoy working with faculty. And that's another thing that's very specific. I mean, I can go over my specific things. You can read the papers. People are important, right? People produce ideas. One thing that's unique at Maryland, Professor Larry Davis and I, we have worked so closely. I mean, we call each other academic brothers, because I don't want him to be my real brother. He's a little difficult. So, academic brothers, right? So, work together on every proposal we wrote. And there is a CS style, his view of thinking, ECE style, my view of thinking. Best proposal we produced. Every effort from IARPA and DARPA. Maryland was there. So the idea here is learn to collaborate. Don't just sit in your corner and so on. Not everybody is easy to collaborate, but the ones that you can work with always is better. I mean, in fact, there's only one another model like this. Ed Reisman and Alan Hansen at UMass. They used to work very closely, okay? And then it's Davis and Chellappa. The reason, because we both had the same mentor, Asriel Rosenfeld. So when I came here from USC, if I didn't do it, he would have been very disappointed, because he was my mentor, right? So we worked together. So that's very important, because you do more by working with people. Okay, so we just working on a couple of projects for IARPA. One is on unconstrained phase verification. And the thing is, before 2012, computer vision people were the happiest people. Nothing really worked. Everybody thought it would work. That's the best place to be as a university professor, always 10 years from now, right? Government was funding us like crazy. We were writing great papers, going to meetings, workshops, conference. Life was good. Suddenly in 2012, something called deep learning showed up. I mean, it used to be there before. Shallow learning, it disappeared. I actually did some work on that, 86 to 96. Disappeared, and then it came back big time. What happened? Added more layers, big computers, stochastic gradient descent. Suddenly everything started to look like it's working. We are not used to that. Really, we're not used to that. So 2012, AlexNet, you know about it. And so government started believing, so you have to do something really big, something that works, something that can, work and go to various government labs and so on, and ridiculous expectations in terms of performance. So we had no choice but also jump into the deep learning world. So the thing is, everybody is doing deep learning. So how do you separate you from the others? So you have to come up with some novel ideas, right? So we talk about multitask learning and all kinds of things. So we built I could say, one of the best face verification systems that a university can build. Okay, 6 university partners for us, and the government did a smart thing. They gave us a very good API, so we can fold everything into it. So before this deep learning revolution came, we will build computer vision algorithms. It will take few months, sometimes years, for this to work at some other place. So whenever my code worked on the other student's office, I said technology transition accomplished. Sometimes even that was hard, because everybody's computer has slightly different software environment and so on. Deep learning, what it did, in addition to keep everything modular, very good software portability. We'll build the software at a university software, right? And then we'll send it to some big place, and they'll run it in 15 minutes. They reproduced our results, and they were able to take their operational images and process. We have not seen that before in computer vision. That's important. That's why there is every person in Bay Area thinks he can start a company, download something, and then do something and become a billionaire, right? That's right. The entry level cost is now very less, $50K or something. So this is a good thing. And then we also have another project. For example, look at the performance. I can make 1 in 10 power 8 mistakes when I say I'm good, 70% accurate. We have never seen that. This is another program we are working on, unconstrained action detection in trimmed videos. Diva and Professor Srivastava is part of that. And then, of course, everybody complains about not having enough data for training your deep networks. And as I think David mentioned, that the ideal thing would be to use synthetic data as your training, because you already have the labels. So we showed how it can be done for semantic segmentation using generative adversarial networks, the 2018 CVPR paper. And I belong to the so-called generative school. We tried to model everything. Models were not good before, but look what GANs can do now. Boy, look at the quality of picture GAN generates. One of my former students, Mingyu Lu, is Mr. Big in GAN, in NVIDIA. I just give a sketch, that's it, they make a big portrait. Okay, so very, very good generative models. So how much time I have? 1 minute, Tom? Okay. Open issues, plenty. So we're going to be working on it. Of course, there is all this thing about attacks and things like that. We have some work on that, defense GAN. Anyway, you can, just Google my name, some Google Scholar, all the papers come, download and read them and be happy. If you have any thoughts on computer vision, come and see me. I'm in 4th floor, just 3 doors down from Abhinav, I think. And Abhinav is a new professor, and he already has 15 PhD students. I think in about 20 years he would have graduated whatever I did in 40 years.